So this is part 3 of special angles on parallel lines, and hopefully this will be short as well. Trying to make them shorter, not longer, and break it up. Here we have two lines. I know they appear as segments, but it's just how it's drawn. And then I have this line that intersects the two, and we would call that, yes, a transversal. Now, for the most part, when we're talking about a transversal cutting two lines, it's of very little interest to us because nothing special, nothing, as I would say, magical happens. But when two lines are parallel and they're cut by transversal, some things that occur that are interesting, some things that are interesting actually occur. That's better said. And that's because of this. And this is one way that I see what's going on. So if I grab this intersection and drag it up, it's not wanting me to do that. You will see when I lay this over there that it's pretty clear that this angle is going to be congruent to this angle. And what do we call those two angles? These here. This angle and that angle. They are in the same relative position at their respective intersections, and those would be corresponding angles. So corresponding angles. And those would be congruent. As you could tell when I dragged the lower intersection up to the top, they appeared to be the same measure. And there we could do some deductive reasoning, but understand that that's going to be true. Now, does that apply to all of the corresponding angles? Let's see. Is it pretty clear that this angle will be congruent with this one from when I drag the intersection up there? And then let me ask you this. What can you tell me about this angle and this one here? Mr. Cook, they're vertical, so they are congruent. Those two angles are vertical angles, so they're congruent. And then this angle is vertical with this one, so those two are congruent. And then we have these two that are corresponding, so I told you corresponding angles are congruent, so that kind of works out. And then the same sort of thing can happen over here with the red ones. Those two are congruent, vertical angles. This one is congruent to this one, corresponding angles. And of course it works out. It has to. Vertical angles. But there's something else going on too. So I've never used the color purple. What about this angle and this one? Those pair of angles, what would we call those? Think second video, second video, second video. Those are alternate interior, because they're interior to the parallel lines, interior angles. Wow, that's all kinds of messed up. Alternate interior angles. And when I have parallel lines, alternate interior cut by a transversal, alternate interior angles are going to be congruent. Because look, it's happening over here too. And what about these two? What would we call those two that I circled in blue? Alternate exterior angles. So a pair of alternate exterior angles might be congruent. Does it work universally? How about that one and that one? That's another pair of alternate exterior angles. So when I have parallel lines cut by a transversal, I'm going to end up understanding that the two pairs of alternate exterior angles are congruent. The two pairs of alternate interior angles are congruent. And that each of the, you can figure out how many, each of the pairs of corresponding angles will also be congruent. So, if two parallel lines are cut by a transversal, then corresponding angles are congruent, alternate interior angles are congruent, and alternate exterior angles are congruent. So then the next question I have for you, what if I just happen along, as I'm living my life, And I'm walking down the street, and I see two lines, and they're cut by a transversal. And I pull out my trusty protractor, and I measure this angle right here. And let's say that I get 72 degrees. Then I walk over to the other line, and I choose the angle that corresponds to this one. And I measure it. And it happens to be also 72 degrees. My question to you is, what can we conclude about those two lines? Because this is what's going to happen, right? 72, 72. What's this one going to be? 108, 108, 108, 108. And so it turns out that the corresponding angles are all congruent. The pairs of alternate interior angles are congruent. The pairs of alternate exterior angles are congruent. And what can you tell me? What can you deduce about the two lines? That they are, in fact, parallel. And that's kind of a new term. We talked about it in class. The converse of this conjecture is also true. So the converse of the parallel lines conjecture, and again, I'm not interested in you memorizing the names of the conjectures. If two lines are cut by a transversal to form pairs of congruent corresponding angles, congruent alternate interior angles, or congruent alternate exterior angles, then the lines are parallel. Of course, that's the symbol for parallel. So that should be enough, at least on this topic. See you next time.